All right. In order to write a balanced neutralization equation, you first have to recognize its neutralization reaction. So you're typically looking for a hydroxide base, so something with the OH right here. You'll notice that all three of these have hydroxide or OH as part of their formulas. And you're looking for something that's going to act as an acid, which are typically things that have H at the fronts of their formulas, like the sulfuric, hydrochloric, and nitric acids that you see right here. Anytime a strong acid and a strong base meet, the H's and the OH's are going to meet first, and that's going to produce water. You can write it as HOH if you prefer, but it's easier to write it as H2O for now. So that gets rid of my H's, that gets rid of my OH's. Now you'll notice I'm aware that there are two H's here. I'm not going to worry about that right now because it's just one H that's going to meet this OH. I'll deal with the mismatch in quantity when we balance the equation. But H's meet OH's to produce water. Now, whatever's left is going to make a salt. So I've got Na and I've got SO4. So I'm going to write those next to each other. NaSO4. Now, Na has a 1 positive charge, SO4 has a 2 minus charge, which means that when they come together, I need two NAs to make this work, Na2SO4. And now I've handled the part of this where I just worked out each particle and how they came together. Now I need to balance this. How many NAs came in? 1. How many are coming out? 2. So I'm going to put a 2 here to fix that. SO4's 1 and 1, so I'm going to keep SO4 as it is. But now I've got two OH's meeting two H's, which is going to give me 2H2O. And there's your balanced equation if you work everything out. Coming down here, I'm going to use that same process. I'm going to eliminate the H and the OH's to make H2O. And then I'm going to put the barium together with the chlorine. Remember that the positive always goes first, so barium being a metal is going to be written first. And then chlorine. Barium is a 2 plus from your periodic table. Chlorine is a 1 minus, which means that when these two come together, it's going to be BaCl2 for charge matching. All right, now balancing. So, and just a quick reminder, I've handled all my particles. Everybody that needed to come together has come together. I'm going to look at my Cl's first. I see 2 and 1, so I'm going to put a 2 here to fix that. Bariums are good. I've got two H's meeting two OH's, which is going to give me two waters again. And there you go. Your equation is balanced. Come down here, same idea. H meets OH to make H2O. And then the K and the NO3 are going to meet and make KNO3. K is a 1 plus, NO3 is a 1 minus. I don't need to do any charge matching here. Now I just need to balance this. 1K, 1K, 1 OH meets 1 H. That makes 1 H2O, 1 NO3, 1 NO3. This equation is already balanced as written. And that's it.